Alright, your test 19 study guide. A quantity of ideal gas was confined in a container of fixed volume. So you say ideal gas, that immediately gets me P1 V1 over T1 equals P2 V2 over T2. The fact that the volume is fixed simply means the volumes are irrelevant in this problem. So P1 over T1 equals P2 over T2 is going to be what I'm going to work with. I can see that the pressure, temperature, volume values are given me are all these scientific notation looking numbers. So the easiest way to do this, it wants the final pressure. What was the final pressure when the temperature is changed? So if I cross multiply, what I'm looking for is what P sub 2 is equal to. So if I cross multiply, I get P sub 2 T sub 1 is equal to P sub 1 T sub 2. That product equals that product. And if I want to get P sub 2 equals, it's just going to be P sub 1 T sub 2 over T sub 1. I'm going to create a formula to find what I'm looking for involving the three things that I need to deal with. The initial pressure is 400 times 10 to the 6 newtons per square meter. The initial temperature is 0.0006 times 10 to the 8 Kelvin. And the final temperature is 0.0002 times 10 to the negative third Kelvin. So if I identify those things, I just need to do the pressure times the final temperature over the initial temperature to get the answer I'm looking for. So P sub 2 is simply going to equal some big fraction here. P sub 1, which is 400 times 10 to the 6th, times T sub 2, which is 0.0002 times 10 to the negative third, and divide that by T sub 1, which is 0.0006 times 10 to the 8th. So again, if I go ahead and create a formula, I can just go ahead and create an answer, then my calculator can evaluate that answer for me. So I'm going to put parentheses, 400 times 10 to the 6th, so not hitting the times key, but hitting second, comma, so 400 E6 times 0.0002 EE negative 3. So the entire top is encased in parentheses, divided by parentheses 0.0006 EE 8 in parentheses. The entire bottom encased in parentheses. It equals, and we get 0.0013 repeating. And that is newtons per square meter. If it came out scientific notation, by all means leave the answer scientific notation. That one came out as a decimal number, so a decimal number would be fine for that one. Number 2, estimate the location of the line indicated by the data point shown, then write the equation that expresses salt, which is the y-coordinate as a function of carbon, the x-coordinate. So S for the y-coordinate, C for the x-coordinate. And it does say identify the 2 points you use to find the equation. You can see the line's not drawn, so we have to draw the line first, preferably with a straight edge. And you kind of get a feel for the data. It's kind of starting off here and kind of going up in this general direction. So I would start at one of these 2 points down here, maybe this one here, and kind of split it up like that. That looks pretty good. I could even go with that. I kind of want to play around with a little bit. To me, that looks pretty good. Some of the data below, some above, and it kind of goes through one of them. It kind of fits the trend of the data. The points I'm going to use are going to be this one down at the bottom and this one up at the top. I want the points separated as much as possible. And be careful to use a bottom or a top or an end point like that, that you actually see the scale going on. 10, 8, 6, 4, 2. This is 0 going down. 200, 160, 120, 80, 40, 0. So this is actually 0, 0. It's not always 0, 0. So I would pick, my 2 points are going to be 40, 0. X-coordinate first, y-coordinate second, and this point up here is 160, 10. It's very important you have to list those 2 points on your paper so I know what points you use, so I can check your answer based on the points you use. I do expect all decimal answers in this. Do not give me fraction answers. So step 1 is to find the slope of the points I picked, so y2 minus y1 over x2 minus x1. That comes out to 10 on top and 140 on the bottom. Oh, sorry, 120 on the bottom. So if I type in 10 divided by 120, we get 0.083 repeating. So let's go 0.0833. Right? Once I know what the slope is, I go back to my points. I'm going to pick this point and this slope. So y equals m times x plus b. So y is 0, x is 40, m is 0.0833. 0.0833 times 40 comes out to 3.332. So if I move the 3.332 to the other side, we get b is equal to negative 3.332. So I know what the slope is. I know what the y-intercept is. So that's my answer. So S equals 0.0833c minus 3.332. And again, decimal slope, decimal y-intercept, all decimals, all the time. Do not give me fraction answers on these problems. I'll expect to see the line drawn. I'll expect to see where you pick the points, you identify the points you're going to use, and the correct linear equation based on the points you've picked. Number 3, write 23i minus 42j in polar coordinates. Step 1 is r is equal to the square root of 23 squared plus 42 squared. Squaring things always makes things positive, so do not ever put negatives in this step. Square root of 23 squared plus 42 squared in parentheses equals 47.89. Step 2, alpha is equal to the inverse tangent of the second over the first. This step requires you to use absolute value bars, which makes everything positive. If you go ahead and assume everything positive, you don't have to put the absolute value bars in. Inverse tangent of 42 divided by 23, you can see I'm in degrees, comes out to 61.29 degrees. Step 3 requires me to identify a quadrant. So 23i horizontal is positive, 42j vertical is negative. So that takes me down here in the fourth quadrant. In the fourth quadrant, theta, what I'm looking for is 360 minus alpha. So 360 minus 61.29 is 298.71. All right. And if we're going to polar coordinates, the magnitude and the theta are the two things we need for the polar form. So 47.89 at an angle of 298.71 degrees. Number 4. This is exactly the problem on the test. It's going to be exactly this. So basically, you don't have to memorize the answer. You just have to apply the completing the square technique to this expression. What I'm going to put up here is what I'm going to expect to see on your paper. So the first thing I'd expect to see will be the division by a and the movement of c to the other side, this being divided by a. So divide by a, you get x squared. Divide by a, you get b over ax. Divide by a, you get c over a, which moves the other side, becomes negative c over a. Gap it here and here, because we're going to have to include something extra there. Okay. To complete the square step, I'd expect to see where you do the fraction squared, and the fraction is half of b over a. Okay, you double the denominator, so b over 2a, and that is squared. And then over here, I'm going to actually square it, so b squared over 4a squared. So I would expect to see that on your paper, where you created this completed square thing. I'm going to expect to see where you got a common denominator. This is 4a squared. This needs to be 4a squared, so times 4a times 4a. The next thing I expect to see in your paper is a factored form here. Square roots of the perfect squares, sign in the middle term squared. Combine like terms here. So I expect to get to this point. An object squared equals an object. Next line down, you take the square root plus or minus the square root. Do it here. Don't put square root signs on this step. So just have that step written there and just go ahead and let the square root happen here. So square root of this drops the power. Square root of the top you can't do. Square root of the bottom is just 2a. And then all you got to do is move the b over 2a to the other side. This is the answer I'm looking for. I deduct partial credit for this, and I do not allow test corrections on this problem. So that's what I'm expecting on your paper. If it's mostly there, you're going to get all, if it's there, you're going to get all credit. Forgetting the plus minus probably costs you a point. Not putting in one of the steps is probably going to cost you a couple points. So I'm expecting to see that on your answer. Now 5 and 6 are both solving quadratic equations. You can use completing the square if you wish. You can use the quadratic formula. I'm going to go that route. If I'm going to use the quadratic formula, it does require that structure. So again, if I'm going to use this formula to find answers, I have to have everything in descending order equal to 0. So that's the first thing I'm going to do is move these guys to the other side and arrange in descending order. So positive 4x squared, positive 5x plus 3 is equal to 0. That tells me a is equal to positive 4, b is equal to positive 5, and c is equal to positive 3. I'm going to go ahead and create the structure of my answer. And I just have to evaluate this thing, and this thing. What goes right here is negative b. So b is 5, so negative 5 goes there. What goes right there is 2 times a. A is equal to positive 4, so 2 times a is equal to positive 8. And what goes inside here is b squared minus 4ac. I'm going to actually evaluate that. B squared is 25 minus 4 times a times c. Just substituting a and c in. A and c are both positive. B is positive, but b squared is always positive. Times 4 times 3. So 25 minus, that'll be 16 times 3 is 48. So negative 23 is what we get out of that. So that's my answer. The last thing I got to do is simplify my answer as best I can. This has a negative in the radical, so I have to take the I out. So make that positive, make that an I. And if I do get an imaginary answer, I want it split. So the real part, 5/8, plus or minus the imaginary part, 23/8 I. So that'd be the final answer. I can't make that any prettier than what it is. So that's the final answer for that one. Number 6, same issue. I got a equals negative 2, it's got to equal 0, so I'm going to move that over. So 5x squared plus 8x plus 2 is equal to 0. Once again, I can identify a, b, and c. A is positive 5, b is positive 8, and c is positive 2. Once again, I know x is going to equal something plus or minus the square root of something over something. What goes here is opposite of b. B is positive 8, so opposite of b is negative 8. What goes here is 2a. A is positive 5. 2a is going to be positive 10. And what goes in here is b squared minus 4ac. That's going to be 64, 8 squared, minus 4 times 5 times 2. A and c are 5 and 2. 64 minus, it is 4 times 5 is 20 times 2 is 40. 64 minus 40 is 24. So there's my solution, and again, that's the answer. All I got to do now to my answer is beautify it, make it as pretty as possible. That means reducing things, simplifying as possible. Currently, this doesn't reduce because this doesn't have a number in front of it that reduces with it. But 24, if you did a factor tree, 2 times 2 times 2 times 3, pull a 2 out, we're going to get 2 times the square root of 6. So x equals negative 8 plus or minus 2 times the square root of 6 all over 10. At this point, the numbers attached to that term, and that term are all even, so they all divide by 2. So the best final answer here is going to be negative 4 plus or minus the square root of 6 over 5. And I do expect you to get all the way down to the most reduced answer every single time. If you leave it here, I'm going to take off half credit because you guys know how to do that. I expect you to do it. So reduce the radical, and then if all these reduce by the same number, I expect you to reduce that fraction. The number inside the radical is not affected by all this reduction. From here to here change because of this. But once it becomes the simplest it can be, only the numbers outside are going to be reducing. Number 7, I see a factorable denominator in an addition of fractions problem. So the first thing I want to do is factor that denominator. So 3x minus 2 on top as is. Factored form, negative 4 times 1, negative 4 plus 1, so x minus 4x plus 1. The second fraction is what it is, 2x minus 3 over x plus 1. I am expecting you to see the fact that x plus 1 is already common, so all that we have to do to make a common denominator is this has an x minus 4 that this is missing, so we need an x minus 4 attached to this. So x minus 4 goes on top, which has to multiply by the entire numerator. Notice the signs all match up properly, so everything's fine as far as that's concerned. What's left to do now is to simplify as much as possible. So before I go ahead and start adding like terms, if I just simplify this expression using FOIL, so 3x minus 2 is going to stay as is over x minus 4 times x plus 1. If I FOIL this, 2x times x is 2x squared. Outside negative 8x, inside negative 3x makes a negative 11x. And then last times last makes plus 12. And again, the common denominator is already there, so what's left to do? They're being added together. Addition means we just, whatever signs are, is what they are. So all I got to do to add these together is combine like terms on top. 2x squared, 3x minus 11x is minus 8x. Negative 2 plus 12 is plus 10, all over x plus 1 times x minus 4. I expect the top to be completely simplified, the bottom can be left in factored form. Don't expect this to reduce. I'll leave it there. You might see 2, 8, and 10, everything's even, but there's no even number on bottom as a factor that would allow you to cancel. So no reduction possible. It probably won't be able to reduce on the test either. Stop there. Number 8, we've got two expressions involving r and t subscripted p, r and t subscripted c. So these r's are different, these t's are different. This product is 400, that product is 80. So what I'm expecting to see on this is that these two facts down here both relate to the same subscripted expression. So r sub p and t sub p can both be substituted here. So that would be my first step here. So if I do that step, r sub p gets changed to 4r sub c. T sub p gets changed to t sub c plus 1. So this t sub p changed into multiple objects, t sub c plus 1. So again, anytime you substitute more than one object, parentheses goes around the substitution. This times this equals 400. Again, we did a replacement here, a replacement there. It still equals 400. So that's step 1. Do a substitution of the bottom two into one of the top two equations. Then you distribute, simplifying as much as possible, 4r sub c t sub c plus 4r sub c is equal to 400. Not required, but probably going to happen. Every one of these numbers divides by 4. That is legal. It's worth doing. In my book, it makes the number smaller. So to divide everything by 4, you get r sub c t sub c plus r sub c is equal to 100. Everything divided by 4. And what you should expect to happen every time in these problems is one of the objects in here should have a known value. So I don't know what either one of these equals individually, but the product of these two things is 80. That's what I've got in my problem. So change this to an 80. Everything else stays as is. And if 80 plus r sub c is equal to 100, that means r sub c must equal 20. Okay, my job is to find all 4 of those things. So r sub c is equal to something, t sub c is equal to something, r sub p is equal to something, t sub p is equal to something. I just figured out what this is. Then if I go back to my original problem, anything containing r sub c is going to help me find something else. So this can help me find t sub c. So this says r sub c, which is 20, multiplied by t sub c is supposed to equal 80. That means t sub c must equal 4. Now anything containing r sub c or t sub c will help me find something else. Well, if I look right here, T sub p, something I don't know, is equal to T sub c, something I do know, plus 1. So T sub p must equal 4 plus 1, because that's what T sub c is. So T sub p is equal to 5. Now anything containing r sub c or T sub c or T sub p will help me find r sub p. So if I just went, let's say right here, r sub p, something I don't know, is equal to 4 times r sub c, something I just found out, which is 20. And that means r sub p is equal to 80. If you test out these answers, all 4 of these answers make all 4 of those equations true. That's a real quick, easy check on these problems. If I multiply the p subscripted variables, 80 times 5, I get 400, check. 20 times 4 equals 80, check. 4 times 20 equals 80, check. 4 plus 1 equals 5, check. Everything is the same, so it means it's the right answer. So you can always do a quick check there, make sure that the outcome answers you get, all these answers, make all the original equations true. Number 9, simplify. First step of simplification is ignore this and figure out what this is simplified. And simplifying that means that if I just take it over here, d over d plus 1 over cd. The only fraction is 1 over cd. I need to multiply each object times cd, the common denominator. So times cd, and times cd. And that gets me cd squared on top, cd squared plus 1 on the bottom. So this fraction is equivalent to that fraction, but that's a simple fraction. So I have c squared, my ignored object, added to my simplified second object, cd squared over cd squared plus 1. Next, I get a common denominator for these. C squared is currently over 1, so it needs to have this entire denominator put on it. So c squared over, I need to put a cd squared plus 1 on the bottom, which means I need to put a cd squared plus 1 on top. The second fraction already has cd squared plus 1 on the bottom. So again, c squared is what it was. Top and bottom both got multiplied by cd squared plus 1, creating the common denominator between the two fractions. If I distribute this, I get c cubed d squared plus c squared for the first numerator, added to the second numerator, cd squared. All that goes over cd squared plus 1. No like terms on top, so that's as far as I can possibly go. And could be a temptation to reduce. Everything has a c except for that, so nothing reduces. These all have d, those don't. So again, I wouldn't expect this to reduce. Just make sure that you're carrying through the process correctly. Most people mess up because they take it a little lax on this. They don't really go through the process here. They multiply these by cd but forgot the top, something like that. So be careful that you fix that first, put it back into the problem, create a good common denominator, simplify everything correctly. Number 10, multiplication of complex numbers. So 1 plus 2i is being multiplied by 3 minus 4i. So first of all, we just do a basic FOIL. First times first is 3. Outside times outside, positive times negative makes a negative. 1 times 4i is 4i. Inside times inside, positive times positive makes a positive. 2i times 3 is 6i. And last times last, positive times negative makes a negative. 2 times 4 is 8. I times I is I squared. And you should expect always to get these 4 objects when you multiply complex numbers. 1 real, 2i to the first, and 1i squared. The I squared object is just a real number in disguise. I squared is -1. The negative changes the sign to a positive, and then whatever the number is. So then if I add my reals, 3 and 8 make 11. If I add my imaginaries, -4 plus 6 makes positive 2i. So that's the extent of that problem. That's how they always are. So FOIL it. Real, I to the first, I squared. I squared is real, change the sign, and then add or subtract based on the signs at that point. Number 11, again, solving a quadratic equation. Once again, I'm going to use the quadratic formula. So it already has everything equal to 0. A is 2, B is -3, and C is +4. So be careful. The other two problems we solved was everything positive. Now we have a minus sign in it, so that creates a negative number here for B. Once again, I create my structure for my answer. X equals something plus or minus the square root of something over something. What goes in the upper left-hand corner here is the opposite of b. b is -3, so I put a +3. What goes in the bottom is 2 times a. a is +2, 2a is +4. What goes in the square root is b squared minus 4ac. Notice, even though b is -3, b squared is still +9. b squared is always positive. Minus 4 times a times c. That makes 9 minus 8 times 4 is 32. That makes -23. And just like problem number 6, I believe it was, we have a minus sign inside the radical, so change to a plus, which creates an I outside the radical. Since I got an imaginary number, I'm going to split my answer into the real part, plus or minus the imaginary part, with the I outside like so. Square root of 23 is prime. I can't make it any better than that, so that's the best answer possible for that one. Number 12, simplify the cube root of 25 times the 4th root of 5. Our first priority is the inside of this whole thing. Ignore this until the end. That 3 does not matter till the very last step. So I'm going to keep a cube root. Then I'm going to modify each of these things. So 25 is 5 to the 2nd power. That's being multiplied by 5 to the 1/4 power. All right, so I want to write both of these in power form. A radical is the inside divided by the outside. For a number raised to a power, you just got to see 25 is 5 squared. If it's 125, 5 cubed, whatever. But again, this is irrelevant until we fix this. Okay, we're multiplying the same base, which requires me to add the powers. If I do 2 plus 1/4, I get 8/4 plus 1/4, which is 9/4. My final step to fix this is to multiply this times that. So I get 5 to the 9 over 12. So the cube root just makes the bottom this many times bigger than what it was. All right, so 5 to the 9/12, which is the right answer. I would expect you to see that it reduces. So 5 to the 3/4 is a better answer. I'd give you full credit for that answer, but always reduce fractions. It's a good habit. Number 13, similar type of problem, different technique. So here, a radical inside a radical requires us to go through this technique. Radical times a radical, I'm going to change each thing to a fractional power. So if you look at this one, they're both 5th roots of these power expressions. So a to the 4th, and then the 5th roots of 4/5 power. And then y to the 3rd is going to be changed to y to the 3/5 power. So inside divided by root to create fractional powers. Same deal here. This is a to the 3rd, this is y to the 1st. They're both being taken the square root of, so there's an understood 2 there. So when I write a to a fractional power, it's going to be 3/2, and y is going to be to the 1/2 power. Once I get everything in fractional power form, then it's just a matter of multiplying the same letter by adding the powers. Adding powers requires a common denominator. So if I'm adding 4/5 and 3/2, common denominator of 10, this right here is going to be 8 over 10. This right here is going to be 15 over 10. Looking at the y's, same deal. I'm adding 3/5 to 1/2. Once again, a common denominator of 10. Top and bottom multiplied by 2 makes 6/10. Top and bottom by 5 makes 5/10. So my final result here, 8 plus 15 makes 23 over 10. 6 plus 5 makes 11 over 10. So I'm expecting an answer pretty much like that for a problem of this variety. So a to some power, y to some power, again, getting a common denominator to be able to add those powers together. Number 14, our job is to find b, which is up here. First off, I can see that we have a right triangle, so finding a is possible. A squared is equal to 7 squared plus 5 squared, which means a squared is equal to 74, which means a is going to equal the square root of 74. And I would like to use decimals on these problems, so I'm going to go ahead and use my calculator. Square root of 74, we get 8.60. So a is about 8.60. I can't find b without finding a, so make sure you do that first. Then if we look at the similarity of triangles here, right angle matches right angle, This angle at the top matches the angle at the top. So small triangle 7, 5, 8.60. Big triangle 11C and 8.60 plus B. They both have that angle. So this angle up here has to match this angle up here. So again, looking at the smaller of the two triangles. So I'm talking about here, here, and here, those three sides. I know that 5, 7, and 8.60, the three sides of that triangle can go on top of that portion. Let's put all that in blue. Then if we look at the bigger triangle, so the bigger triangle's here, look at those three sides, those correspond to the other three sides. So 5 and C both correspond to each other, so 5 and C go in the same fraction. 7 from the blue triangle and 11 from the red triangle correspond to each other. 8.60 from the blue triangle and 8.60 plus B match up from the red triangle. All right? What I'm told to find is B, so even though this is a true fact over here, this is going to help me find what I'm trying to find. Over here does. So, but again, this has to be 8.6, so it can't be A, then you have too many letters. So finding A first is important. So now if I just cross multiply, this product equals that product. So 7 times 8.60, 60.20, equals 8.60 times 11. Let me verify my calculations there. So 8.6 times 7 is 60.2, and 11 times 8.6 is 94.6. Everything's accurate. Okay, plus 7b. Oops, I did that wrong. So worried about getting these calculations right. Didn't do it right. So we'll try again. 7 times this whole thing. So 7 times that makes that. 7 times b makes 7b. 11 times 8.60 makes 94.6. So do it properly. Distributive property, 7 times this, and 11 times that. Equal to each other. So to solve, I got to move the 60.2 to this side. So 7b is equal to 34.4. Divide both sides by 7. 34.4 divided by 7 comes out to 4.91. Again, I'm not asking you to find C, so don't worry about it. But make sure the proportion's set up properly. The most common mistake, 7 over 4 goes here. All right, so 7 and 4 make 11 for the entire side of the red. 8.60 plus B makes the entire side of the red. So be careful that you're adding the two pieces together when they're giving you the pieces of each. Number 15, find the equation line that passes through the point 3, -4 is perpendicular to the line 2y minus 6x equals 5. So let's focus on the perpendicular part first. Perpendicular to the line. All right, so they're telling me that in order for me to find the slope of the line I care about. So they want me to find some line that's perpendicular to this line. So I'm going to start off 2y equals 6x plus 5. Move the 6x over so it's y equals. Divide by 2, same reason. The slope of the line they're giving me is 3. The slope of the line I'm looking for is perpendicular. So again, perpendicular to the line, perpendicular slopes are opposite reciprocals. So change the sign, flip the fraction. That's the slope of the line I care about. All right, again, the slope they gave me was 3, but again, I had to find it. It has to say y equals before I can see the slope. Whatever number's in front of x is the slope. Then you modify it, make it a perpendicular slope. Once I know what the slope of the line I'm looking for is, this line is no longer important to me. Now what I care about is the slope I have, which is negative 1/3. And the point that the line that I'm looking for passes through, which is 3, -4. I go to y equals mx plus b and substitute my numbers in. So y is -4, m is -1/3, x is 3 plus b. I always tell you to do the fractions first. 3 divided by 3 is 1 times -1 is -1. If this comes out to a non-fraction, let it be a non-fraction. I still see on a bunch of people's paper, -1/1. You're making life difficult for yourself. So divide if it divides evenly, multiply the result. So 3 divided by 3 is 1, times -1 is -1. Since this isn't a fraction, leave that a non-fraction. So move the 1 over, plus 1, so you get -3 is equal to b. Slope -1/3, y-intercept -3. Equation y equals slope x plus y-intercept. On the test, it will be a perpendicular line problem. So again, this equation, solve for y, get to a slope. You make the perpendicular slope, then use that slope at a given point to find the y-intercept of the line you care about. This slope with this y-intercept go on the final answer.